Welcome back to the channel. Today we're going to explore a topic that's crucial for modern web applications, enterprise platforms, and cloud infrastructure, and that's single sign-on, commonly known as SSO. If you've ever logged into one service and suddenly found yourself authenticated in several other apps without entering your password again, that's the power of SSO. In this video, we'll walk through exactly what SSO means, how it works under the hood, and why it matters for both user experience and security. Everything you hear will sync with the diagram shown on screen so you can follow along clearly. Let's begin with what single sign-on actually is. Single sign-on is an authentication system that allows a user to log in once and gain access to multiple applications or services without needing to log in separately to each one. It's like having one master key that opens many doors. You don't need to unlock each room individually, because all the doors recognize that you are already authenticated. SSO is commonly used in organizations where employees need to access several internal tools, or in cloud-based services where users move between apps owned by the same provider. This saves time, reduces frustration, and ensures a more seamless experience across digital platforms. Now let's take a look at the core components of SSO. The single sign-on process involves three important components which work together during every login. The first component is the user, which simply refers to the person trying to sign in. The second component is the identity provider. This is the system that performs the actual authentication. It verifies who the user is and generates a token that represents that authentication. The third component is the service provider. These are the applications or services that the user wants to access. They don't handle authentication directly, but instead rely on the identity provider's confirmation. With SSO, users interact with the identity provider once, and after that, the service providers trust the identity that's already been established. Let's walk through how single sign-on works using a real-world example. We'll take Trello, a project management tool, and Google as the identity provider. Imagine a user wants to log into Trello using their Google account. Instead of creating a new Trello account and remembering yet another password, the user chooses the Google sign-in option on Trello's login page. As soon as the user selects Google Login, Trello redirects them to Google's central login service, typically hosted on accounts.google.com. Google then displays its familiar login screen where the user enters their credentials, usually an email and password. After the credentials are entered, Google contacts its own authentication server to validate the information. If the login is successful, Google creates a secure authentication token, often using SAML, and returns it to Trello. Trello receives this token but doesn't just accept it blindly. To confirm it's valid, Trello sends the token back to Google's authentication server for verification. If the token checks out, Trello accepts the login, grants access to the user, and often stores a session so that the user stays signed in for future visits. From the user's perspective, the entire process is seamless. They never type their password into Trello, and they don't log in again for other connected services, because Google has already done the heavy lifting. This is the power of SSO in action: one login, secure token exchange, and access to multiple services without friction. Let's take a look at the SSO protocols. SSO works smoothly because of trusted communication standards called protocols. These protocols define how identity data is exchanged securely between the identity provider and service providers. One of the most established protocols is SAML, which stands for Security Assertion Markup Language. It is commonly used in enterprise applications and internal systems. Another widely used framework is OAuth 2.0. OAuth focuses on authorization and is often paired with OpenID Connect to support authentication. This combination is especially popular for cloud apps and APIs. These protocols ensure that identity data is securely transmitted and that tokens can't be forged or intercepted. Now let's talk about the benefits of using single sign-on, which apply to both users and organizations. From the user's point of view, SSO makes life easier. You only need to remember one password, and you don't have to sign in again and again as you move across services. This reduces login fatigue and improves the overall experience. From a security perspective, SSO reduces the number of credentials in use, which also reduces the attack surface for things like phishing or credential theft. Strong policies like multi-factor authentication can be enforced centrally through the identity provider. For system administrators, SSO simplifies identity management. Permissions, access levels, and policies can be managed in one place, making it easier to onboard and offboard users. In short, SSO improves usability, strengthens security, and streamlines operations. Of course, as with any technology, SSO has its risks and limitations. The biggest risk is that SSO can become a single point of failure. If the identity provider is down or compromised, users may be locked out of all connected services. Another risk is that if an attacker gains access to a user's account, they instantly have access to every system that trusts that login. That's why it's absolutely critical to combine SSO with strong authentication methods like biometrics or two-factor authentication. Implementing SSO also takes careful planning. You need to make sure tokens are correctly validated and that services are properly configured to trust the identity provider. If the setup is rushed or incomplete, it can lead to major security holes. So while SSO improves a lot of things, it must be deployed thoughtfully and securely. To make it more relatable, let's consider a few real-world examples of SSO in action. When you sign into your Google account, that single login gives you access to Gmail, YouTube, Google Drive, Docs, Calendar, and more. You only enter your credentials once, and Google handles the rest using tokens and internal trust. Another example is Microsoft's ecosystem. Logging into a Microsoft account gives you access to Outlook, Teams, SharePoint, OneDrive, and other Office 365 apps, all through one sign-on. In the enterprise world, companies often use platforms like Okta, Azure Active Directory, or Auth0 to provide secure single sign-on access to a wide variety of internal and third-party applications. SSO makes these ecosystems more efficient, more secure, and easier to manage at scale. So to wrap up everything we have discussed, single sign-on is an authentication method that allows users to access multiple applications after logging in just once. It's built on trust between an identity provider and one or more service providers. It improves user experience, increases security, and simplifies identity management across platforms. SSO depends on protocols like SAML, OIUTH, and OpenID Connect, and while it offers great convenience, it must be paired with strong authentication and thoughtful implementation. If you found this breakdown helpful, make sure to like the video, subscribe for more developer-friendly content, and leave a comment if you have questions or want us to cover related topics. Until next time, keep learning and keep building.